We have one more graphical example to look at here, slightly more complicated graph. Now we're calling it h prime. We've left off the h from the x-axis, and again, we have the entire domain. So since it's a graph of h prime, let's start with the easy questions first and answer, for example, these three. Where is h prime greatest? We don't want to look at the slope of this graph. That would be h double prime. So where is h prime greatest? Simply, where is this graph at its highest point? And that's when x is b. Where is h prime least? It just says where is this graph of h prime at its lowest point? That's at e. Where is h prime 0? We don't look at the slope of this graph. We look for where its y value is 0, which happens twice, c and g. Let's do the other two h primes. Where is h prime increasing most rapidly? Meaning, where is this graph on the board going upward most steeply? And that should be at point F. And then where is h prime decreasing most rapidly? Where is this graph on the board going downward most steeply? So we're going downward pretty steeply at C, but then even more steeply at D if you draw your tangent lines carefully. So h prime is decreasing most rapidly at D. If we're following the same order from last time, now we can try to answer these two. H is increasing most rapidly. That's when you want the slope of h to be most positive, meaning where is h prime most positive? So that's the same as asking question D. H is increasing most rapidly at B. H is decreasing most rapidly. You want the slope of h to be a big negative number, meaning you want h prime to be a big negative number, because remember, h prime is the slope of h. So if we're saying that we want h decreasing rapidly, that means we want the slope of h to be a big negative. Slope of h is the same as saying h prime. So this question is saying, where is h prime most negative? So h prime is negative all this way, and h prime is most negative at E. And let's do the last three. Where is h greatest? So what do we know about the graph of h? H prime is positive from A to C. So what's h doing from A to C? H is increasing from A to C. And then what is h prime all the rest of the way? H prime is negative. So what's h doing all the rest of the way? H is decreasing. So if we tried to sketch a graph of h would be increasing from A to C. And then what would h be doing all the rest of the way? H would be decreasing. So the answer to the question of where h is greatest is where? That's at C, right? Because h increased prior to C, decreased after C. So the only possibility is C. Now where is h least? There might be two possibilities if I hadn't drawn the graph so carefully. H increased from A to C and then decreased from C to I. So either h was lowest at the start or at the end. But if we look at here, the time that h is increasing from A to C is much shorter than the time that h is decreasing from C to I. And the rate at which h is increasing, meaning how high above the x-axis we are, is less than how low below the x-axis h prime gets. So the amount that h increases from A to C is much less than the amount that h decreases all the rest of the way. So that's why I drew the graph this way. H increased a little bit, and then h decreased much, much more than that, meaning h ended up at its lowest point at I. And finally, where is h 0? Just as in the previous example, we can't answer that question because even though I drew a graph of h that crossed the x-axis here, I could just as well have drawn one that stayed all the way below the x-axis or stayed above the x-axis all the way. So this one, we don't have enough information to determine that. Again, all we know is about the shape of h. We don't know where h is positioned relative to the x-axis. And we're going to add to this some questions about intervals. So on what interval is h increasing? So we know h should be increasing when the slope of h is positive, meaning when h prime is positive. So let's be careful here. We want to look at the original graph that was on the board. This is h prime. So h prime is positive from A to C. So I'm going to write closed A, open C, but honestly, it's just a matter of conventions. Different books indicate whether to include the endpoints or not. They have their own conventions, and it's not a question that's really worth worrying about. So if you put open A, closed C, or just write A to C, that's fine. All that's important is getting the endpoints right, not whether they're included or not. For example, the people who write the advanced placement calculus exam, which is given all around the world, they're careful never to mark a question wrong because a student did or did not include an endpoint, because they know that different students have studied with different books and different teachers, and the books and the teachers have a variety of conventions about whether to include endpoints or not. So it's not worth getting upset about. H should be decreasing when H prime is negative, so certainly from C to G, and then from I. And the question again is whether you want to include G or not. I don't care, but to me I would say we should include G, because even if you're sitting on the graph of H right here, if you look the tiniest little bit backwards, you look up, and if you look the tiniest little bit forwards, you look down. So H really is still increasing at G. So I would say all the way from C to I. But if you want to say C to G and then G to I and not include G, that's perfectly fine. Doesn't make any difference. It's not an important thing to worry about. And the last two, H prime increasing. That's just when the graph on the page, on the chalkboard, was increasing. Not the new graph, but the original graph of H prime. So H prime was increasing from A to B, and then again from E to G, right, going upward. So A to B, and what did I say for the other one? E to G. And then H prime will be decreasing when the graph on the board at the start was going downward. So that graph was going downward from B to E, and then a little bit at the end from G to I. And again, don't worry about whether to include the endpoints or not. It's just a matter of convention. Different books, different people do it differently. I hope you've enjoyed our first week of actual calculus with derivatives. We've looked at them as formulas. We've looked at them as word problems, like with the hummingbird. We've looked at them numerically with the values that we got, like when we plugged into 1.1 and so forth. And we've looked at them graphically, all the 4 different ways that we're supposed to be looking at things under reform calculus. Now we have an applet for you where you can play around by typing in different formulas for f of x and trying to predict what the f prime would look like. It's a good exercise leading up for next week and to help you do these sorts of problems. And we have a check your understanding for you to do, and we'll see you next week.